Hey y'all, welcome back from spring break. It is so good to have the opportunity to learn and to continue to grow even in the midst of all that is going on. I'm so glad that you are healthy and that you are here and that you are ready to learn. We are going to continue this e-learning thing for the rest of the school year, as you know. And we're going to continue with learning about permutations, okay? Let's start with a couple of reminders first. Remember that e-learning is required every day. Email me if you have questions, and you can still submit any assignment that you are missing. So if you are missing things from quarter 3, like back when we were actually in the school building, you can turn that in. Or if you're missing some e-learning assignments, then you can also turn those in. You can check the gradebook and look for zeros. If you see zeros, that means it's missing, and that's what you need to do. Okay? No late penalty. So I wanted to let you know that I'm not going to be grading for completion anymore. I am going to be grading your homework, the IP, for accuracy. Okay? Because of this, I will no longer give you a bell work or a skill check. You'll just have time to focus on watching the video and completing your IP. Okay, so here's the new procedure that the IP will be graded on. So like I said, I will grade for correctness, not completion, but partial credit will still be given. So you can always attend office hours and redo any IP that you aren't happy with, okay? All IP will now be worth 10 points in the gradebook. So if there are 35 points on an assignment, then this is what I'll do. I'll take 27 and divide it by 35. And then you'll get a 0.77, and I'll move the decimal place one place to the right, and you'll get a 0.7 out of 10 in the gradebook. This is nothing that you need to memorize or nothing that I want you to write down. I just basically want to just inform you of how I'm going to be grading your work out of 10 points. This is going to help you see more clearly what we're doing in class. I've already been doing this out of 5 points, but now I'm changing it to 10 points, okay? So 9 is an A, an 8 would be a B, a 7 is a C, and anything below that is an NG and should be redone. All right, so at this point, you should be using your Riverside email address. That email is your first name, your last name at riversidehighschool.org. This makes it much easier for you to access materials and allows me to contact you reliably if necessary. If you are not using that email and don't know how, please email me and I can help you set that up. From now on, all Google Forms will require you to use your Riverside email address. Okay, so this is for those of you who have not been doing it. If you have been doing that, awesome job to you. My office hours are going to be Monday through Thursday from 10 to 11. Remember, we do not have any e-learning requirements on Fridays. And as my big spring break announcement, I finally downloaded TikTok and I did the dance for Savage by Meg Thee Stallion, and it's pretty good. I'm definitely not going to give you my TikTok name, but if you find me on there, let me know. All right, so before we start, here are some ways that you can be successful on this lesson today. I want you to complete the lessons in order. So if you have not yet done previous e-learning assignments, go back and complete those first. I want you to watch the video before you complete the assignment. Don't complete the assignment, then watch the video. Watch the video, then complete your assignment. Take notes to refer to while you complete your assignment. So do you have pencil and paper out right now? If not, I want you to pause the video and get your materials. Okay? When the video says to pause and try the problems on your own, please do that. That's really helpful for you, and you need the practice before you complete the assignment on your own. If you're unhappy with your grade after you submit your assignment, you can email me for help and resubmit it for a better grade. Remember, assignments are now graded on correctness, not completion. So if you say IDK or leave it blank, that gets you a 0. Okay? All right. So before the break, there was an error on the last IP on counting principle number 10. I didn't count this question against your score because the problem was not correctly written, but I wanted to show you why it doesn't work. Then we will do some practice on simplifying rational expressions in the bell work. Okay? So this problem, you will need to factor the numerator. So basically, we need to find two numbers that multiply to -8 and add to -3. Well, I know you all wrecked your brains and you thought about this and thought about this and thought about this, and you realized there were no magic numbers that worked. Some of you thought that -5 and 2 were the answer, but when you multiply -5 times -2, you get 10. Positive 2, you get -10. Not the -8 that we need. So this would not work, okay? So because we could not find the numbers, we realized that the numerator cannot be factored using the tree rule, okay? The only way that this actually can be factored is by using the quadratic formula. Lucky for you, we are going to be learning about the quadratic formula in the next upcoming weeks, and you will be able to factor a trinomial that looks like this, okay? All right, so right now, pause the video and complete the bell work below. Remember, it's really important to keep practicing these problems so that you don't forget everything while we are gone. I will go over the solutions if you get stuck, okay? I apologize if you hear my dog. He's just barking away. So I've been working this out. Okay, so what we had to do first was find the magic numbers, -1 and -6. And that's what I'm going to substitute in for -7x. And that's what you see right here. So I have -1x minus 6x. I added those x's behind those values. Then I need to group my first two and my second two terms. And I can take an x out from the first two terms, and I can take out a -3 from the second two terms. I group what's left, which is x minus 3, and then I have 2x minus 1. And then from there, I substitute it back into my numerator, my answer, and I can cross out what they have in common. Okay, the answer is what's left. All right, let's try this one here. So we need to factor the denominator. So we need two numbers that multiply to -15 and add to a +2. So that would be a 5, and negative 3. We have our magic numbers. Let's substitute those in for 2x. So we'll have x squared plus 5x minus 3x minus 15. We can group our first two terms and our second two terms together. From our first two terms, we can take out an x, and we'll have x plus 5 left. From our second two terms, we can take out a negative 3, and we'll have x plus 5 left. The insides of both of our parentheses are the same, so we know we did the right thing. So let's take out that x plus 5, and then the x minus 3. Okay, we're going to plug that in to our original problem and see what cancels. Remember, something is always going to cancel. So those cancel. Well, I have nothing left on the top. Okay, but I know x minus 3 is on the bottom. So when I have nothing on the top, when those two cancel, I don't put a 0 there, because when I divide 0 by things, I get 0. What I need to write is a 1. Okay, great job on this. If you'd like to pause this and go back, that'd be perfect. Please do so. Email me with questions. All right, so we are going to review some of our counting principle skills. So last time we learned about the counting principle. If you haven't already done the lesson on counting principle or didn't do well on that assignment, I encourage you to stop here, go back and complete that lesson, and submit or redo that assignment, as you will need those skills today. Here's an example problem from the last IP that we did. Let's look at two ways to do this. We can either do it with a tree or by using the counting principle. Okay, so let's start by using the tree method. Number 3 says you are looking at used cars. You find some with the following options: colors in black, white, or red, with or without air conditioning, and with or without automatic transmission. How many different possible cars are available? So with the tree, we're going to start with our first 3 options. Okay, our first options are going to be black, white, and red. So we'll create our tree. We'll put black, white, and red underneath. Now we know that our black, white, or red car can either have air conditioning or not. So we want to create 2 options from each of our colors, and we're going to have AC or no AC. A white car with AC or a white car without AC. A red car with AC or a red car without AC. Okay. Last thing that we can have as an option is a red, black, or white car with or without AC, or with or without automatic transmission. Okay, so we're going to have 2 options coming from our AC or no ACs. And from here, we'll write automatic transmission or no, 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 and automatic transmission or no. Okay, so remember our question that was provided is how many different possible cars are available? Well, we get that by counting the ends of our stems. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I forgot about this one up here. 10, 11, 12. Okay, so the different possible cars are 12 cars. So with the tree, you start with the first option they give you, then you dissect it into the 2 separate options, with or without air conditioning, and from there, with or without automatic transmission, then count the very bottom, the total, to get your number of cars possible. We can do that same problem, but using a different technique. We're just going to rely on the counting principle this time. So I just want to show you how much easier it is to use the counting principle instead of that tree method. Okay, so with the counting principle, let's identify our main categories. So we have the colors of our cars. There's 3 possible options. We have with or without AC, which gives us 2 possibilities. And then we have with or without automatic transmission, which gives us 2 more possibilities. So with this in mind, since we know the possible outcomes, we can literally just multiply our possible outcomes together, and we should end up with the same answer that we got from before using the tree method. And that is exactly what we'll get. 3 times 2 is 6. And then 6 times 2 gives us 12. So there are 12 cars possible. So we learned the counting principle because using the number of possible outcomes, we can find the number of possible cars without having to go through that tree method. All right, so we are going to add on to our understanding of the counting principle by learning about permutations and combinations. So today we want to extend our learning about these things using the counting principle to discuss permutations and combinations. So permutations and combinations refer to the number of ways in which objects from a set may be selected. When order, which is our first blank, when order is important, that is called a permutation. So when the order of the events happening matter, that's called a permutation. For example, say your locker combination is 5, 4, 3, 2. If you enter 4, 3, 2, 5 into your locker, it won't open because it is a different ordering, aka a permutation. So I can't just take these numbers here and enter them into my locker any way I want, for instance, using 4, 3, 2, 5. In this case, the order of these numbers actually matter, okay? So locker numbers aren't actually combinations. We call them locker combinations, but that's not actually correct. What we should be calling them is locker permutations, okay? They are actually mathematically called permutations. So next time you're in the hallway or you're talking about your locker and how to get into it, you should say locker permutation, not locker combination, okay? So today we will focus on times when order is not important, and that is called a combination. We will surely learn more about permutations later. Is this a combination or permutation? It's important that you are able to identify the difference between a combination and a permutation. Remember, if the order is important, then this is a permutation. Not a combination. Sometimes, when we just need to know the number of possibilities, we can just use the counting principle and multiply, okay? Example 1. In a race in which 6 automobiles are entered and there are not ties, in how many ways can the first 4 finishers come in? We have to ask ourselves, does order matter? Okay, well, when you have cars racing, the order does matter because that's how we award silver, gold, bronze, and vice versa. Okay, so in this case, we have to know the order of which these four finishers come into place, for instance, first, second, third, and fourth. Therefore, this would be called a permutation. Is this a combination, a permutation, or should I just go ahead and use the counting principle? Again, it's important that you are able to identify the difference between a combination and a permutation. Remember, if the order is important, then it's a what? Exactly. A permutation, not a combination. Sometimes when we just need to know the number of possibilities, we can just use the counting principle and multiply. Okay, let's decide if we're using combination, permutation, or maybe the counting principle. So, the model of the car you're thinking of buying is available in 9 different colors and 3 different styles. So you have hatchback, sedan, or station wagon. And how many ways can you order the car? Well, if we were using permutation, does it matter the order of things? Okay. In this case, we're talking about cars that we want. We're not racing them. We're not valuing them in any way. So we really don't care about the order in which we decide which car we want. Okay, so that leaves us to the combination or the counting principle. Okay, well, if we want to use the counting principle, that would work if we can decide our categories and how many things are within them. Okay, so let's see. We have 9 different colors, and we have 3 styles. Well, yeah, we know the number of possible colors. We know the number of possible styles. So we can simply do 9 times 3, which is 27, to get our number of outcomes. So in this case, we would just make it a counting principle problem. All right. One more example of choosing whether or not this example is a permutation, combination, or a counting principle. Let's reiterate this again. This is the 3rd time we're saying this. We're just really trying to hone on how important it is to be able to identify the difference between a combination and a permutation. If the order is important, it's a permutation, not a combination. Sometimes when we just need to know the number of possibilities, we can just use the counting principle and multiply. Okay. Example 3. A book club offers a choice of 8 books from a list of 40. And how many ways can a member make a collection? Okay. We want to know how many ways can a member make a collection. Well, I know that I have 8 books from a list of 40. I want to know the number of combinations that I can make. So this would be a combination problem. All right, I want you to try. I want you to decide whether each of the scenarios below is a combination, a permutation, or should we just use the counting principle. Please pause the video and try these on your own. Go. Part A. A medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered for the test, in how many ways can 6 people be selected? So what are the combinations of people that can be selected? So this is a combination type problem. Keywords here is how many ways. Usually when we see how many ways, we can decide that it's a combination problem. Okay. B, a popular brand of pen is available in 3 colors: red, green, or blue, and 4 tips: bold, medium, fine, or micro. How many different choices of pens do you have with this brand? Key here, they give us categories, colors, and tips, and they also tell us how many are within the category. So how many different choices of pens do you have with this brand? So all we really need to do is multiply 4 times 3, and we can get 12, and that would give us our result. So counting principle is what will be used here. Okay. Last one. A corporation has 10 members on its board of directors. In how many ways can it elect a president, vice president, secretary, and treasurer? We have to ask ourselves, does order matter here? Yes. We can only have one president, we can only have one vice president, we can only have one secretary, and one treasurer. Okay? Since those things can only happen one way, this would be an example of a permutation. All right, let's learn more about combinations. So remember, a combination is when we select some items from a larger set, but order is not important. Let's try some. Example 4. For a segment of radio show, a DJ can play 4 songs. If there are 8 to select from, and how many ways can the program for this segment be arranged? Remember to think about whether the songs would be repeated. All right, so we have 8 songs to start with. So if he's playing a song or she is playing a song as a DJ, and there's 8 songs, the next that song that is being currently played, once it's played, we throw it out of the mix, okay? So how many songs will we have left? We have 7 songs left to choose from, okay? Well, once that song is played, we throw it out. So we no longer have 7 songs because, 8 songs because 2 have been played. We have 6 left, okay? And then once we play that song, we only have 5 more options. We stop when we have 4 values. Okay? We multiply these together and we get 1680 ways, or 1,680 ways for the songs to be arranged, for the 8 songs to be arranged. Remember, a combination is when we select some items from a larger set, but order is not important. Another one. How many different ways can a director select 4 actors from a group of 20 actors to attend a workshop on performing in a musical? Remember to think about whether one person could attend twice. Okay? No, one person cannot attend twice. Okay? So we would start with the number of actors total. Once that actor has attended once, no longer can attend, so we have 19 options. Once those 2 have attended, we only have 18 options left out of the 20. And once those 3 have attended, we only have 17 options left. We stop when we have 4 values. We want to select 4 actors. That multiplication, 20 times 19 times 18 times 17, gives us 116,280. All right, now I want you to pause the video and try this one on your own. Remember, you want to start with 7. Sorry about that. You want to start with 7 and multiply backwards until you have 5 numbers. Pause it and try it. So you'll have 7 times 6 times 5 times 4 times 3. We started at 7 and we multiplied our way backwards until we got 5 numbers. 1, 2, 3, 4, 5. And we have 2,520 ways. All right, combinations with repetitions. How is this problem different than the previous problems? While social distancing, you and your siblings decide to play some games. You have 15 games in the closet. You only have time this week to play 5 games. You decide it's okay to play each game more than once. How many ways can you choose which game to play? Now, in this problem, it's okay if we play each game more than once. So when we play, our first option is 15 because that's the number we start with. Okay? So once I play this one game, I have 15 options to choose from. Okay? They said it's okay to play the same game twice. So once I play the first game and I want to choose my second game, how many games do I have to choose from? 15. Because it doesn't matter if I go back in and choose the same game to play. Okay? Again, I want to choose the third game. It's okay if I play each game more than once. So if I grab, I have 15 options for the third game, 15 options for the fourth game, and 15 options for the fifth game. Okay? These are not division signs. These are options. Let me not make these like that. So this represents the first game, the second game, the third game, the fourth game, and the fifth game. Okay? So we can write 15 times 15 times 15 times 15 times 15 as a base raised to a power. And when we multiply that out, we get 759,375 ways. So when order does not matter, or when we have combinations with repetitions, then we're going to have much more possible ways of doing things. All right, I want you to go ahead and pause the video and try these on your own. Remember to look at the problem and determine whether or not things can be repeated, okay? All right, suppose you decide to put each card back in the deck after you draw it. Okay? How many possible ways can you draw 4 cards? So there are 52 cards in a deck. Okay? So when I pull my first card, I have 52 options. Okay? I pull that first card, I put it back in. When I pull my second card, I have another 52 options because I put that card that I chose, I put it back in the deck. So there's still 52 cards there. And when I take my second card, I put that back. So I have 52 options again for my third card. My handwriting is really terrible in here, I'm sorry. And then for my fourth card, and I'm stopping at 4 because it says how many possible ways can you draw 4 cards. So I want 4 options. This is the first one, second one, third one, and then my fourth one is coming. I have 52 options for my fourth card. So to get my answer, let's write this as a base raised to an exponent, 52 to the 4th power, which gives me 7,311,616 possible ways to draw 4 cards. Isn't that magnificent? That is amazing. Amazing. Okay? All right. Now, suppose you change the game and decide not to put the cards back in the deck after you draw each one. So when you draw your card, you leave it out there with you. And then you draw the next card and leave that one out with you. And then the next card and leave that one out with you. And then the last card and leave that out. Let's see how our number of possibilities will change. Key here. This time we are not repeating. Okay, this time my first card, I have 52 options because there are 52 cards in a deck. I take that card out, I put it on the table with me, and then I pick up the next card, which means there's only 51 cards left. So my second card only has 51 options. My third card has 50 options because I left that second card and the first card out with me. And then my fourth card has 49 options because I left the first, second, and third card out on the table with me. So there's only 49 cards to choose from at that point. So when we multiply 52 times 51 times 50 times 49, we have 6,497,400 possible options. Okay? So remember to note in your examples on your homework whether or not things can be repeated. So if you're going to put, if your total is the same throughout the whole problem, or are you going to leave the cards out? Is your total going to change each time? All right, here is an honors question. Standard, you can also try this one out. This one will be helpful for you. But we're not going to try this one just yet. You'll have a practice problem coming up in just a second. So honors, suppose a theater company is trying to select what they are going to show this year. They have 11 musicals and 8 dramas to choose from, but only have room for 5 shows. They decide to do 3 musicals and 2 dramas. How many ways can they select their shows for the year if they don't repeat any of the shows? Okay, so in this case, honor students, we have 2 categories that we have to look at. We have to look at musicals and dramas. Okay. In this case, for the musicals, we're not replacing them at all. So every time we select one, we have to take that away from our total. So we'll have 11 first times 10 times 9. Okay. We stop at 3 numbers because there's 3 musicals. With the dramas, we have 2 dramas. In our dramas, we have 8 to choose from there. So we're going to start at 8 and then go to 7. We stop at 2 values, 8 and 7, because there are 2 dramas. Let's multiply these together, 990 and 56. We can't stop there. How many ways can we select their shows for the year if they don't repeat? So I told you they don't repeat. That's why our numbers went down every time instead of stayed the same. So we're going to use the counting principle to decide this. We get 990 times 56, which gives us 55,440 ways to select their shows for the year. All right, there are 6 women and 5 men interviewing for cashier positions at Walmart. And how many ways can the 4 positions be filled? Okay, well, we're not given a total to start. We need to add these 2 together first. So we have 11 possible options. So we're going to do 11 times 10 times 9 times 8. We do not repeat, that's why our numbers are decreasing. Multiply these together, get 7,920 ways. And how many ways can the position be filled if the interviewer decides to hire only women? Well, in this case, we're only looking at our value for women, which is 6. So we're going to start at 6 times 5. Remember, they don't repeat. Times 4 times 3. So we have 360 ways to choose from the women. And then in how many ways can the position be filled if 2 women and 2 men are hired? So I'm going to make some space here so that I can better show what I'm going to do here. So women, I will start with, I need 2 women, so I'm going to do 6 times 5, and that will represent women. Then I'm going to multiply by the men options. So there are 5 men, so I'm going to start with 5 and then go down to 4 because there are 2 men that are being hired. And I can multiply these 4 numbers together to get 600 ways. Okay. All right. So now I want you to go back to Haiku and click on the Google form for the IP combinations. Notice there is an honor section at the bottom. Great job. See you later.